In this example, we need to carry out addition and subtraction operations on matrices. So in the first case, we're required to determine the result of the addition of matrix A and matrix B. So as a general rule, here's how matrix addition or subtraction is carried out. So I have A, B, I have this matrix whose elements are A, B, C, and D. So let's take addition, for example. I have another matrix whose elements are X, X, Y, say W, Z. Now the first thing you notice here is that the matrices being added together are of the same order. This is 2 by 2 and this is 2 by 2, and that is a rule. So the first rule, one of the important rules in terms of addition, is that you can only add matrices that are of the same order together. But the key thing is you're adding two matrices of the same order, so the resulting matrix is going to be of the same order. So the matrices we're adding together are 2 by 2, so the resulting matrix is going to be a 2 by 2 matrix. So they're going to be 4 positions. So in this first position here, the result is obtained by adding A and X. So here we're going to have A plus X. In this position here, you're going to have B plus Y. This position here, you're going to have C plus W. And this position here, you're going to have D plus Z. So the value of each position within matrix, resulting matrix rather, is obtained by adding the elements in the matrices being added together that are in the same position. So an example here would make all I just said crystal clear. So for case part 1, we're going to add A and B. So A is this matrix here, 1, 0, 0, 3. I'm going to be adding it to matrix B, which is 2, 6, 4, 8, whose elements are 2, 6, 4, and 8. And to make the addition simpler, I'm going to circle elements in the same position. So elements in the top left corner are going to be circled in red. Elements in the top right corner are going to be circled in blue. Elements in the bottom left corner are going to be circled in green. It's easy to know who to add and which elements add together. So like I said, we're adding two 2 by 2 matrices, so our resulting matrix is going to be a 2 by 2 matrix. So the element in the top left corner is obtained by adding the element circled in red, so 1 plus 2 is 3. The element in the top right corner is obtained by adding the element in blue, 0 plus 6, which is 6. Elements in the bottom left corner are obtained by adding the elements in green, 0 plus 4, which is 4. And the element in the bottom right corner is simply obtained by adding the element in the bottom right corner. The matrix is being added, so 3 plus 8, which is 11. So A plus matrix B gives this matrix whose elements are 3, 6, 4, and 11. Case 2, we're required to add matrix A to matrix A. So there are two ways to do this. You can say A plus A is 2A, or you can actually carry out the addition process as I just did in part 1. So matrix A plus matrix A plus, so that gives 1 plus 1, which is 2, 0 plus 0, 0 plus 0, 3 plus 3, which is 6. Alternatively, you could have said A plus A, it's 2A, that's 2 times matrix A, so you're multiplying a matrix by a scalar, this number here 2, and that will give 2 times 1, 2 times 0, 0, 2 times 0, 0, 2 times 3, 6, which is the same result as here. For case 3, we're actually going to carry out the subtraction operation. So C, matrix C minus B. So that's C minus B. I'm going to circle elements whose position correspond to top left corner elements being circled in red, top right corner elements being circled in blue, bottom left corner elements being circled in green. So the matrices we're dealing with are both 2 by 2 matrices, and because there's subtraction operation, the resulting matrix is going to be a 2 by 2 matrix. So the element in the top left corner is obtained by carrying out, 5 minus 2, which is 3. The element top right corner is obtained by simplifying minus 10 minus 6, which is minus 16. Bottom left corner, minus 3 minus 4, which is minus 7. And bottom right corner is 1 minus 8, which is minus 7. And that's it.